So hello girls. Today we are going to perform the experiment actually on the electrolysis of brine solution. And of course I have prepared a beaker of brine solution which I have inserted into the box of the electrolysis setup here. And I would like to review with you what we have been learning before is that electrolysis. This word in Latin, it means breakdown. Alright, we are utilizing the electricity in order to break down something. And of course, in particular, brine solution refers to concentrated sodium chloride solution. Is it? Alright, so, and of course, it is an electrolyte, okay, containing four kinds of mobile ions. What are they? And of course, it contains like a sodium ion, which is mobile in nature, of course. It contains like chloride ion mobile in nature, and because it is an aqueous state, and because sodium chloride is soluble in water, and that's why H plus and OH minus, because the water will self-ionize, correct? And because we are connecting to a power supply, and there should be a DC power supply, direct current. And when we are having a direct current box here, which we are able to control the voltage of it, and this setup is actually regarded as the chemical cell, correct? Down below here, this part is actually chemical cell. Okay, let me write it here, the chemical cell. And of course, the above part here will then be referred to the electrolytic cell. Electrolytic cell. Alright? So we are having a part of chemical cell here, and of course having positive and negative electrode, which from the negative electrode of the chemical cell, this is the, you still remember, this is the anode, because anode is where oxidation occurs, correct? Which lose its electron. Okay, anode is where oxidation losing electrons. Alright, and it goes up to the electrolytic cell, goes up to this graphite electrode, correct? And of course, returning to the positive electrode of the chemical cell, so electron should be going in. Electron going in. Electron going in. Accepting the electron, it is where reduction occurs. Reduction occurs at cathode. And that's why in the chemical cell, the anode is negative, while the positive electrode is cathode. Alright? And of course, anode refers to the oxidation losing electron towards the electrolytic cell here. And electrons has been accepted by this electrode by some ions in the electrolyte, correct? And that's why accepting the electrons here, this is reduction. Reduction occurs at cathode, okay? At cathode. While at the same time, oxidation occurs at the anode. Anox, red hat, correct? So, but because it is a kind of electrical appliances, having a chemical cell and an electrolytic cell here, so positive is connected red wire to red wire, the positive wire here. This is the positive electrode. While at the same time, negative to negative, okay, negative electrode. And that's why electrolytic cell, the anode is positive. And of course, anode will attract the anions. And the cathode in the electrolytic cell is actually negative in nature, that cathode attract the cations onto it. Alright, based on this, we are able to know that these are the four mobile ions. And because of the fact that hydrogen ions is way more reactive compared to the Na plus here. And that's why from the ECS electrochemical series, you know that the hydrogen ions is attracted towards this electrode. Alright, the hydrogen ions is attracted towards the cathode. Cathode attract cations, that the electrons has been accepted by the hydrogen ions to give hydrogen gas. Very good. So here, bloop, 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 because the water has been displaced out, displacement of water, and here is actually the hydrogen gas. And we will see whether it's true, okay? We will see. And of course, on the right-hand side, because of the concentration, the molarity of the chloride is higher than that of the hydroxide. And that's why the chloride will be preferentially discharged. Okay, the anion is being attracted to the anode here to discharge. So the chloride is losing its electron to form chlorine gas. But of course, as I told you, chlorine gas is slightly soluble in water, and that's why it is quite good when it is dissolved in water. So please remember, when chlorine is dissolved in the water, it gives hydrochloric acid as well as hypochlorous acid, HOCl. Alright? And of course, what is left behind? Okay, when the hydrogen ions and the chloride ion has been consumed, those solutions left behind should be the sodium hydroxide, which is alkaline in nature. And let's check today whether those experimental results here as theory is true. And of course, how we are able to prepare the setup is that we are going to add the brine solution inside the test tube. And because of time, of course, I have prepared those, the other test tube as well as the books already. And we can use the seawater, the brine solution, use a finger, okay, to hold this and to invert this and insert, so that the test tube is actually full of the brine solution. Alright, and of course I have added already the universal indicator, so that you can see it is right now green in color. Okay, because of the fact that before electricity has been conducted, those solution is neutral in nature. Parent acid, hydrochloric acid, parent alkaline, sodium hydroxide, it is neutral, pH 7 for the NaCl. Alright, so that's why it's green. But of course, when I am adding the DC power supply into, like, say for example, like 15 volt, let's see what happens. And by the way, I have already put the stopper inside, so that later I just take out and stopper it and take it out, and you are able to see full of gas. And can, of course, you can observe what happened inside. Okay, let's check. 15 volt. And of course, because the whole test tube has been covered, and that's why the electricity is not that good. But when I take it up and make those spaces for the electrode, let's see. Wow, it's so fast. And observe the color change as well. On the right hand side, it is very bluish, and on the left hand side, it's very yellowish. Alright? And look at the rainbow color down below, huh? Okay, let's see, let's check. Let's check. And of course, the gas collected on the left hand side is quite slow, although theoretically speaking, it should be of 1:1 mole ratio. And according to the Avogadro's law, they should be of the same molar volume. But the problem is, chlorine is slightly soluble in water, that it is quite slow actually. It's quite slow actually. And on the right hand side, hydrogen is quite good. You can actually see those solutions start spilling out because of displacement of water. Those water inside the test tube has been pumped out already. And on the right hand side, so how about I stopper it first? I stopper it with a test tube. Very good. And let's pause the experiment by switching off the power supply first. And see, on the right hand side, we get the gas here because the water has been displaced out because of displacement of water, so that this test tube on the right hand side, what do we test with? Of course, we use a burning flint and see whether pop sound is heard. Okay, a burning flint. Okay, burning flint, and we unstopper it and see. Can you see? Okay, actually there is a pop sound occurred, and it is positive, and that's why it proved it is of hydrogen gas. And right now, the color disappeared already, the trend, the rainbow, and we can see, continue to collect the chlorine gas. And of course, because of the bleaching effect, the indicator, the universal indicator has been bleached actually. And that's why you are not able to see the trend already when I pause the experiment. And of course, I would like the stopper to be vertical. So that later, okay, very good. And it has dominated because I just collect the chlorine gas inside the test tube while the hydrogen just escaped to air. And of course, we need to wait a while. Wait a little bit first. And because of the bleaching effect, the universal indicator has made it colorless already. Make the solution colorless already. Chlorine is actually quite slow, huh? How about I increase the voltage a little bit? Oh, it's maximum already, 15 volts. And of course, on the right hand side, those gas evolved is actually the hydrogen gas. So it is safe for me. And the chlorine gas has been trapped inside the test tube here. As you can see, water has been slowly displaced out. So please wait for a while. Don't sleep, wake up, wake up. And of course, can you see the color of the gas here collected? And I start smelling a swimming pool smell, okay? The chlorine smell already, huh? Can you see the yellowish green color formed in the test tube? The kind of gas, although it's very pale, okay, pale yellow. Okay, yellowish green, this kind of gas. Great! How about I now collect the gas? Okay, and stop. So, when I take out the gas here collected, which is yellowish green in color, can you see? Actually, from the white tile. I hope you are able to see. And what do we test with? And of course, we need to prepare a blue litmus paper. So I have it here. And of course, when we are having the blue litmus paper, what we are doing right now is that we make it wet. Okay, we make it wet first with a water bottle, okay, with a water bottle. So that it is wet in color, and we should be able to observe this yellowish green gas, okay, yellow gas here, when I insert it, because it is acidic in nature. When the gas is reacted with water, give hypochlorous acid and hydrochloric acid, and also there should be a bleaching effect, just like why it has been decolorized here. Okay, let's see. It becomes red and completely white. Alright, and of course I cannot let you smell here, but let's see. It is yellowish green and it got a very huge swimming pool smell. Okay, the bleaching effect because of the hypochlorite ions. Alright, and of course the solution here left behind as the concentration of the sodium hydroxide increase, and of course we are able to test with a red litmus as well. But I doubt whether the bleaching effect also works here. But I would expect that it will give a blue color, alright, because of the presence of sodium hydroxide. And let's see whether it works. Okay, red litmus, okay, it turns blue as well. Oops, can you see? It's not that concentrated, but it turns blue. It turns blue. Alright, so we have proven that the setup here, because of preferential discharge, we are able to get the chlorine gas, and chlorine is slightly soluble in water, that it becomes hypochlorous acid, and the remaining solution was alkaline in nature, and that's why you were able to see from yellow to green to blue. Originally, huh? And later, because the bleach has leaked out, and that's why it bleached the entire setup. Alright? So I wish you have a very nice day. I hope you will learn something from the electrolysis setup. And if you have any questions, feel free to ask. I will see you in the lesson. Bye bye. Love you.